Hello, this video is on solving quadratics using the quadratic formula. There are two learning targets that are attached to this video. The first is I can find the discriminant of a quadratic equation, and I can use the quadratic formula to solve a quadratic equation. So on the bottom of this first slide, you can see the quadratic formula there. It is kind of long, so it says x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So the nice thing is that the quadratic formula can be used for any quadratic equation. So if you like this one, it's a good strategy to use for lots of different problems. Remember that our quadratic equations are usually in the form of ax squared plus bx plus c. That's standard form. That's what we like them in when we're solving, if we're going to use the quadratic formula. So just remember that this is the same thing as y that 0 is, but when we're solving, we are making y equal to 0. So as an example, on the bottom in blue, I have y equals 2x squared plus 4x plus 7. So in this case, I just identified the a, b, and c as if we were going to actually solve it. So in this case, a is 2. So that's what I'd plug in for a in the formula above. B would be 4, and C would be 7. We're going to go through a couple different examples in this video. Okay, so the discriminant, that's going to be a vocabulary word you want to be familiar with. It's just the part that was under the square root. So you can see on your notes the quadratic formula from the previous slide. The discriminant is the portion b squared minus 4ac. So it's just a small part of the actual formula. The discriminant is helpful because it can tell us how many solutions that the problem will have. This is nice because if you look at the discriminant first and you see that there's not going to be any solutions, well, you're saving yourself some work then. So if the discriminant, b squared minus 4ac, if it's greater than 0, so for example it's 3 or 5 or 100, you will always have two solutions. Next case is that b squared minus 4ac, so the discriminant is equal to exactly 0. In that case, there will only be one solution. And last case scenario, if the discriminant is less than 0, there will be no solutions. That's because we can't take the square root of a negative number. So the discriminant will tell you how many solutions that you have. Using the whole quadratic formula will tell you exactly what the solutions are. So here, the discriminant, it won't tell you what the solutions are, but it does tell you how many you should have. Okay, so for our first examples, it just says to identify how many solutions, so how many solutions each quadratic has. It doesn't say that we have to actually solve. So in this case, if they're just asking about how many solutions, I'm going to use the discriminant to help me out. So I just need to know b squared minus 4ac. So remember, the a is the number with x squared, b would be here, and c is here. So a is 3, b is 10, and c is 2. So if I follow the b squared minus 4ac, I'm going to have 10 squared minus 4 times a times c, and then I'm going to use PEMDAS to simplify. So I end up with 100 minus 24, which leaves me with 76. 76, so remember the discriminant, we're comparing it to 0, is greater than 0. So that means I will have two solutions. So that quadratic would have two solutions. Looking at my quadratic on the right, x squared plus x plus 1, let's make sure we know our a, b, and c first. So for that one, a would be 1 because there's no number there. B is also 1, and C is 1. So if I follow b squared minus 4ac, I end up with 1 squared minus 4 times a times c. 1 squared is 1 minus 4 gives me negative 3. Well, negative 3 is less than 0. If I look at my chart, when I'm less than 0, there are no solutions. And I can stop there. Okay, moving on to some examples where we are actually solving. It says use the quadratic formula to find the solutions for the given quadratic equations. So in blue, I rewrote the quadratic formula. You guys will get the quadratic formula on the test, so you don't have to have it memorized, but you want to be familiar with it. So in my first example, I have 2x squared plus 3x minus 5. You can see in pink, I already wrote out that a is 2, b is 3, c is negative 5. You don't have to write that step out, but sometimes it can be helpful. So if I start following my equation, I have the opposite of b, so that gives me negative 3 plus or minus the square root of b squared, so 3 squared minus 4 times a times c, and that's all over 2 times a. So there's quite a bit going on here. My preference is usually to simplify under the square root first and go from there. So I still have the negative 3 out front, plus or minus. 3 squared is 9, and then negative 4 times 2 would give me negative 8 times negative 5 would give me a positive 40, so that turns into plus 40. And in the bottom I have 2 times 2, which is 4. Now on my next step, I'm just going to combine this 9 plus 40 here, so I end up with negative 3 plus or minus the square root of 49 over 4. Now my last step is to simplify the square root of 49. That's going to give me a whole number, 7, so I'm going to end up with negative 3 plus or minus 7 over 4. Now from here I'm almost done. But because of this plus or minus right there, I'm going to want to split this into 2 equations to solve. One's going to be negative 3 plus 7 over 4, and my second is negative 3 minus 7 over 4. So if I solve the one on the left, negative 3 plus 7 over 4, well, that gives me 4 over 4. So one solution is x is equal to 1. Remember, we're solving for x here. Second one, negative 3 minus 7 is negative 10 over 4. I am going to simplify that, so x would be negative 5 halves. Those are my 2 solutions. All right, moving on to the next one. This one's 2x equals x squared minus 3. It's not in standard form yet. I need to move that 2x to the other side to get them all together. So my equation really is 0 is equal to x squared minus 2x minus 3. So in this case, a is 1, b is negative 2, and c is negative 3. Again, you don't have to write this out, but I think it's a good step in the beginning. So my formula says x equals the opposite of b, so x equals opposite of b would be 2 plus or minus the square root of b squared, so negative 2 squared minus 4 times a times c, and that's all over 2 times a. So that's what I have at this point. I'm going to simplify under the square root first. So when I do that, I have x equals 2 plus or minus 4, negative 2 squared is 4, and then minus 4 times 1 is negative 4 times negative 3 gives me positive 12. And in the bottom I had 2 times 1, which is 2. Continue simplifying under my square root gives me x is equal to 2 plus or minus the square root of 16 all over 2. And then here again, I know the square root of 16 is 4. So at this point I have x is equal to 2 plus or minus 4 over 2. So once I'm at this step, I know I need to split it. So first one will be 2 plus 4 over 2, and my second one will be 2 minus 4 divided by 2. Again, some of this you can probably do in your head. That's fine. I'm just showing you every single step in the examples here. So 2 plus 4 over 2 is 6 over 2. Gives me 3. 2 minus 4 is negative 2 divided by 2. Gives me minus 1. So my solutions here are x is equal to negative 1 and 3. There are 2 solutions. Okay, got a couple more examples to go. I encourage you guys, if you're starting to feel comfortable with this, go ahead, pause the video and try it, and then just check your work when you're done. So here a is 1, b is negative 2, and C is negative 4. So again, I'm just going to follow my formula. So x equals opposite of b, 2 plus or minus my square root. I have b squared minus 4 times a times c, and that's all over 2 times a. So as usual, I'm going to start with just working under that square root. Negative 2 squared is 4. That ends up being plus 16 over 2. So I'm left with x is equal to 2 plus or minus the square root of 20 over 2. So now in this case, I'm going to pause for a second. The one thing that's different is that the square root of 20 is not a whole number. It's not a perfect square. So if that ever happens, as long as it's not a word problem, so like here we're just solving a plain equation, you can actually leave your answer just like this. And then that would represent the solutions here. Okay, last one we're going to do is a word problem. It says a model rocket is launched from the roof of a building. Its flight path is modeled by h equals negative 5t squared plus 30t plus 10, where h is the height of the rocket above the ground in meters and t is the time after the launch in seconds. Alright, so part A says, what is the initial height of the rocket? When I hear the words initial height, initial is like the same thing as starting. So to me, that implies that that is when the time is equal to 0. And I know when the time is equal to 0, that's the same thing as my y-intercept. So what they're really asking for is, what's the y-intercept here? Where does the rocket start? So if you guys remember, when we're in standard form, the c value in our equation is our y-intercept. So that tells me that our initial height is 10 meters. A little sloppy there, sorry. Okay, part B says, when did the rocket reach its max height? So they want to know the time it took to reach that max height. So if you guys imagine a parabola, right, this rocket's going up and coming down, that max time is going to be at that halfway point, which is the same as our axis of symmetry. So to find that, I need to use the opposite of B over 2a. So if I plug in what I have, that would give us negative 30 over 2 times a is negative 5. So I have negative 30 over negative 10, which tells me it was at 3 seconds. That's when it reached its max height. What was the rocket's max height? Well, the max height is going to happen at the AOS. So we're going to go back and plug in the 3 for the 3 seconds for time. So I'm going to get h is equal to negative 5 times 3 squared plus 30 times 3 plus 10. And again, follow order of operations. Get negative 5 times 9 plus 90 plus 10. Negative 5 times 9 is negative 45 plus 90 plus 10. That gives me 45 plus 10, which is 55 meters. So max height was 55 meters for this rocket. Okay, last part is still connected to the same problem, so still working with that model rocket, but they want to know how long did it take for the rocket to reach the ground. Well, the rocket's on the ground. I know the height is actually going to be 0. So what they're saying is, okay, if the height is 0, so 0 for h, so the rest of my equations stayed the same, what's the time? So at what times is the rocket on the ground? So really what they're asking us to do is to solve the quadratic. So at this point, we can use the quadratic formula to help us. So here, a is going to be negative 5, b is 30, and c is 10. We're just going to follow it along. Again, if you haven't stopped and practiced yet on your own, go ahead and do that, and then check it against my work. So opposite of b, negative 30 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So if I move on to simplifying, I have negative 30 plus or minus the square root of 900. 30 squared is 900. And then if I simplify this, minus 4 times minus 5 times 10, That's going to give me a positive 200. And then the bottom, I have 2 times negative 5, which is negative 10. So I'm going to continue simplifying. Negative 30 plus or minus the square root of 1100. I got that from doing 900 plus 200 over negative 10. And then I took out my calculator and I found the square root of 1100. So I did mention earlier in the video that if you get to this point where this square root doesn't give you a whole number, you can stop if it's not a word problem, but this is, so we want to get our actual solutions. So I'm going to keep going. So I have negative 30 plus or minus. The square root of 1100 was 33.17, I rounded, and that's over negative 10. So now from this point, I can split it. Sorry, I'm running out of room here. So I'm going to have negative 30 plus 33.17 over negative 10, and negative 30 minus 33.17 over negative 10. I simplified both of those. So negative 30 plus 33.17 gave me 3.17, and then I divided by negative 10, and I got negative 0.317 as my first answer. Second one, I did negative 30 minus 33.17, and I got negative 63.17, and I divided that by negative 10, and I got 6.137. So here I'm showing 2 answers, but I have to remember I'm talking about an actual scenario here where a rocket's in the air. So it's saying that one solution could be that the time this happened at was at negative 0.317 seconds, and the time it happened was again at 6.317 seconds. But if I'm talking about time, it can't be negative. So the negative 0.317 I'm going to cross out. The only real solution here is the 6.317 seconds. Thanks for watching.